or the title of the section of 2.8. Present value. Present value of investments, like what is it worth right now versus in the future? Because generally, again, like I said, if you get cash right now, you can actually do things with it, let it work for you over time, right? And the closer you get it to now, the more you could potentially earn with it by investing it or using it for other things, right? So in other words, so there's two ways to think about investment, right? A lot of times maybe you want to retire. Maybe you want to have $1 million to retire, right? So you can put some money into an account that earns interest. You can put it, we're talking about putting in the stock market, so we're leaving that aside right now. We're not talking about gains from value. We're just talking about an interest-bearing account, okay? And let's say you want to have $1 million and you're going to retire in 30 years. How much should I put in the bank right now so that it will grow to $1 million 30 years from now? Well, the question, how much do I put in right now? That's present value, right? So there's two ways to do that. You can either put one lump sum in and just let it grow, or what else could you do? You know, because you read this stuff, right? Yeah, you could put it like each month. You could put, you know, $500 into this account, right? So there's two different formulas for that. Okay, there's two different formulas for that. So let's define what present value is. Present value, or PV, right? There's also a net present value you hear about with this. We're not going to get into that in that course. It's slightly different, right? So it's a current value of an investment required to achieve some value in the future, okay? It's the current value of an investment required to achieve some value in the future. Okay, I think again, if you want to retire with $1 million in 30 years, there's some present value you could put in the bank. And, you know, a certain interest rate, and it should grow. So we can do it with a single deposit or multiple. So we'll talk about single deposits first. Kind of goofy how they set this up. Example one, they go through and they kind of derive the future. So what they do is they take the future value formula and they solve it for P, principal you need. I'm just going to give you that formula outright instead of going through all that. I think it'll be a little more useful, right? So we could do present value of a single deposit. Right? Just put it in one time, let it ride. Hopefully you have your $1 million, right? So that would be P, that principal, the original present value, right? Equals B, the balance that you want at the end of some time, divided by 1 plus R over N to the NT, okay? Of course, N's a number of compounding periods per year, T's a number of years, okay? So this would be another formula for your note card, okay? That B, remember the top, is, let's say I wanted $1 million in 30 years. I would have 1 million on the top of this fraction here, okay? And 30 in for T, monthly in 12, etc. Okay? Let's take a look at example one now that we have the formula. So, you know, we'll do it like once by hand here, right? And then we'll take a look and see how the calculator does it, okay? So in example one, and they're going to go through and derive it, but I already gave it to you. I what's going on there in example 1? Page 116.
Mr. and Mrs. Johnson know that in 6 years with a daughter and will attend state college. So we need about $20,000 for her first year's tuition. How much should the Johnsons deposit into an account that yields 1.5% interest compounded annually in order to have that?
Okay, so it's a single deposit, right? So let's just plug into the formula. Present value of what they need to deposit is B. So the B is what they want. How much do they want to have? $20,000 divided by 1 plus, what was the rate? 5%? 1.5? 0.015 compounded annually?
Yes.
Yeah, I think I'd find something compound a little more frequently, wouldn't you? Yeah. To the NT, to the 1 times the number of years is going to be, is it 16? Did they say, I think you had to do the math there. What did they say?
In 6 years.
Oh, why do I have 1 6 there? What was it on my glasses on? That looks like my 1 times 6 looks like a 16. Right? So you can carefully push buttons on that, and you should get $18,290.84. All right. So everybody, just right now, make sure you can get that figure with this formula. Take a second. Plug those numbers into your calculator. Okay. So it should just be 290. I might have to get my actual vision checked. 290. All right. Let's try it with the TVM solver. Now that we're on the same page, so on the catch. You remember how to do that? So it'll be a little different than the last time. We're going to be solving for a different line on that TVM solver. Remember how to get in there? You can use Scratchpad or open a new document. It doesn't really matter, right? So if you remember, go in here, just open your Scratchpad, and you hit Menu here. So that bottom one, Finance, 8. You just want that first one, Finance Solver. Enter. Okay. Now remember, the N is all the compounding. Remember, see, it's a capital N. So how often is this compounded? Well, 6 years, but how it's compounded? Oh, just 1. So it's like technically it's 1 times 6, right? Or just 6. Okay. Now the rate was 1 point. Remember, we don't change it. Notice it says percent on the calculator screen. So it'll be 1.5 technically divided by 1, right? So just 1.5. We could. I'll put it in just so you can see. Divided by 1. Technically, is what you should do. Okay. Now the PV there, you see, that's what we're looking for. So we don't have anything for that yet. So we'll leave that with a 0 in it. Just skip past it. And do you see this field that says payment? We're not doing any payment, right? It's 1 time. We're depositing in there. So you can probably guess we'd use that for the periodic deposit, right? So we'll leave that one blank. Oh, yep. Leave that blank. And how much do we want? $20,000? And that would be coming to you, so was it positive or negative? Put in here. Positive, 20,000. Okay? So we want that PV, that present value, so just arrow back up to it. Get in there and hit enter. It should be about the same as what we got with the formula. Right? Got it? Not too horrible, is it? It's the worst. I don't know about that. Okay. So just to refer back to this technically. So for the N field, right, you'd put in 1 times 6. Right, and then you'd have the I percent, right, going to be 1.5 divided by 1. I wish they'd use something else in there, right? The PV is what we're gonna, right, just hit the enter key once we get everything in there. Right, and then it'll give us the value. We don't have anything for payment, so that'll be 0. And the future value, FV, and that will be the 20,000 we want. You notice that came up negative on the calculator, right? Why is that? You're just going away from you to the bank, right? For now, and then when it comes to you, you get 20,000, right? Let's try the check real quick on that. I want you guys to, let's see, how much is that? So it's a lot like the one we just did, in example 1, except just for 2 years. Right, do the check, do it with the formula there, and see what the difference is.
Would we use 40,000?
What you got?
Would we use 40,000?
No, they still want 20,000, right? But they want it in 2 years now instead of 6. Maybe they should have started sooner, right? Well, first of all, what do you suspect the present value will be in this one? Higher or lower than for 6 years? Yeah, you're going to need more. You got less time, right? So still 20,000 by 1 plus 0.015, 1 to the 1 times 2 this time. What do we get? Oh, well, why is that 40,000? How much was the Johnson? They want to.
They want to pay the first 2 years of tuition.
Man, why do I have 40? What made you say 40,000?
Because the first year of tuition is 20,000. So
Oh. Ah, see for 2. Okay, I got it. Yep, that's why I had 40,000 in there. Yeah, 2 years is 40,000. Good catch, Carly. You're a crackerjack. 40,000. But they only have 2 years, right? No, that's the 2 years. Holy cow. It's still 6. I was thinking this was going to be, I thought they were setting this up different for some reason. Still 6. How much are they going to need? Good gravy. Get about 36,581. No? Oh, because remember we changed it to 40,000. And we probably straightened this out. But anyway, 19, right? So let's see, like, take your answer. You said 19.4. So he did it the way I was originally thinking they were going to set it up, right? So instead of 6 years, they only had 2 years. So instead of depositing 18,290, they need to deposit the 19.4. Is that what you said? That was really what I was hoping to get at with that one. But, all right. Okay. Let's take a look at example 2. But I think we'll just use the TVM now. All right. Let's do example 2 with the time value of money function there in the calculator. Dylan, what's going on in example 2?
Chico's treasury funds shows a 2,000 efficient account after 10 years. How much she deposited in account now at 0.95? Sometimes you
What was the rate? 0.95%, right? So that's 0.0095, right? That we have to use there if we're going to do the formula. And how long do they have? 10 years. Let's do it with the TVM. Okay, so open that up there. So the N, what's going to go in for our N? 365 times what? Remember, this is all of them for the whole term. It's 365. It's compounded daily times the 10 years. Remember, in this thing, they want all the compounding terms. Okay? Our I percent interest as a percent. What are we going to type into that field? 0.95, not 0095, right? Remember in here, so 0.95, wait a minute though, what? That's the annual rate. Divided by what? No. No. How many times is it compounded per year? 365. We need that daily, right? So divided by 365, right? So take a look at the N, right? The N, you're multiplying by 365, but when you go in the rate, you got to divide by 365, right? So present value, we don't know yet, right? We're going to hit enter there in a minute. And there's no payment being made. And how much do they want? $100,000 positive. So we'll keep a 0 in for payment. So you're going to put all that in, right? And see what it spits out. So we'll put that in there. So I'm going to do 365 times 10, and then 0.95 divided by 365. I'm going to just put a 0 in there for now. Nothing there. We want 100,000, right? Is that what you guys got? Notice it says negative 90. 937, 41, right? So you want to have a negative 9437.41, okay? That's negative because you need to start with that in the beginning, okay? So you put that 90,400 in the bank for 10 years at that really, really low interest rate. Excruciatingly low. I think you probably want to find another way. I mean, it's compounded nicely, you know, daily. But I'm thinking you could probably right now find some other investment vehicle, like probably put it into the market or something, or buy gold, right? Okay. All right. So that's a couple with the single deposit. We know how to do the formula, right? And now we know how to do it with the TVM solver on your calculator. On the test, I will ask you to use the formula, but you can use that thing to check yourself, right? It'd be helpful. Did they get this right? You know? All right, let me give you and they do it again. They derive this thing in the example. So I'm just going to give this to you. The present value of a periodic deposit. Okay? That's kind of a messy little formula. And they try to derive that there in example 3. Look at that. It's just, I mean, I'd have fun with it, but we don't have time in this 5-week thing to monkey with this kind of stuff. So it's just this. Boy, you're going to want that on a note card. Okay? The P now is the amount of your current periodic, the amount you deposit each month or whatever, right? Okay? That P now stands for the monthly, whatever the periodic deposit is. Okay? It's the amount you want, balance, times R over N. Okay? This mess here. Over a giant mess down here. 1 plus R over N to the NT minus 1. Okay? definitely gonna wanna parenthesize around the bottom there when you put it in and the top, okay? Remember, in this case, the P doesn't necessarily stand for the initial deposit, it's the periodic deposit amount, okay? So let's take a look then at example 3. So Nick wants to put in an air conditioner in 3 years. Estimates it's going to cost him $15,000. So he's going to put a little bit away each month, huh? Well, it's a central air conditioner for the whole home. And, yeah, could very well be, right? It's not like the window units, right? It's all down the basement, big whole deal, right? And I'm sure that parts and labor too, flat labor. So he's got an account, pays 1.4 interest, compounded monthly. So how much does he have to put away each month for 3 years, right? So that's periodic. So you got to know. So like these are a lot of formulas here, right? I think you know how to use them and be careful with them. But the trick is, right, know when to use each one. Okay, so you got to read carefully. So example 3, periodic deposit. All right. So his time horizon is 3 years, right? He needs to have a balance of 15,000, okay, at a rate 0.014 we'll use in the formula, and it's compounded monthly, okay? So let's just plug and chug. So his payment each month, right, is going to be the 15,000 times R.014 over 12 divided by 1 plus 0.014 over 12, right, to the 12 times 3 NT and minus 1 out there. And go ahead and put that, let's make sure you guys can get that, okay, your calculator. You're definitely going to want to group the top and group the bottom here. You'll do some nesting. Okay. So put that in there and see if you can get what it should be, which is 408.22. Not using the TBM, just trying to put the formula in. Let's try it with the TBM there and verify we can get the same thing. So now that part that we haven't been using, right, we're going to use what's going to go in for the N field, guys. 12 times 3 in the I percent field. What goes in there? 1.4 divided by 12, okay? Now, the present, we're not making a deposit, right? We're not making a single deposit, so we're going to leave that PV as 0, right? But what's the next one, though? That's the one we're looking at, right, David? So we'll leave that as 0 for now. And again, the future value is the thing where we need 15,000. So you'll put all that in there, and you'll hit enter. And hopefully you'll get negative 408.22. And again, it should be negative because it's going away from you. You guys able to get that? All right. 3, 4 divided by 12, 0 for that, 15,000. Back. And so there you go, it's negative. You good with that? Pretty handy little feature, isn't it? Huh? All right. One more example. They just want to kind of graph this thing. If we were to graph this with time on the x-axis and the amount you need to deposit to reach some goal on the y-axis, what do you think would happen in the graph as time increased? X. So, let's say, one example, we had 3 years to reach our goal. The next example, we're going to have 10 years to reach our goal, right? How do you think that will affect the amount that we have to deposit to reach that goal as time gets larger? You don't need to put as much in, right? Because you're letting it grow for longer, right? So when you think the graph might come down, well, it's exponential, so it might curve down, right? So let's put this, in example 4, they want us to put in this graph here. Randy, he wants 200 grand, some point in the future. We haven't decided at what point. So maybe you can do this graph and kind of see where you are and how much time you want to give yourself, right? 1.2%. And he wants to do periodic, right? Okay. So again, instead of that n times t, we're going to just replace that with an x, okay? And so that axis, it will be time, but it will be not in years, but what? If it's compounded monthly, and that, well, let me just do this. Let me write the formula. Okay. So he wants the following here. The amount of this monthly payment. He wants 200,000 and times 0.012 divided by 12, right? All over 1 plus 1/2 over 12. Now instead of the n times t up there, we're just going to use x. And that'll represent our n times t, 12 times whatever number of years, right? So we're just going to put an x up here, minus 1. So if it's compounded monthly, that x-axis is now the number of months. You gotta be careful, right? All right. So let's go ahead and put this in our TI, right? You're going to need to group top and bottom, okay? So we'll have, okay, this is our time in months, right? Because it's n times t is our x-axis. And this will be our amount of our periodic deposit. Okay? I'll sit down and do this. It'll be easier for me. Let's see if we can get it put in correctly. Let's see if I got it right. We're going to have to change the window, aren't we? So let's think about like how high we need this here. Like if you only had 1 month to do it, you'd have to put in almost a full $200,000, right? So I'm thinking my window should have the Y's going from 0 to at least 200,000. Let's see, we'll actually go from 0 to, it's in months, right? So let's try 10 years, so 100%. try 120, see what happens here. 0 to about 250,000. I might have to adjust the x-axis there. That kind of gets it, right? So what's happening there? As time increases, in other words, as he has more time to let it grow, he can make a smaller monthly deposit to reach his goal. Does that make sense? Okay? So it's something like this. Okay? As time goes on, right, is a smaller monthly deposit required. Okay? So I would just say as the horizon, right, time horizon, right, number of months, okay, the required deposit each month decreases. So the required deposit decreases. Okay? So if we go out here, we had a graph like out to 10 years. If he's got 10 years, he doesn't have to put much in. If he's back here, he only has 1 year to reach that goal. He's got to make 12 giant monthly deposits. That's him, right? I know it's easy to think about, you know, as time increases, this thing should go up as it's sitting there. Well, no, that's only if it was like the balance at the end, talking about how much you need to put in. So it's like almost an inverse. What about the check for that one? Read the check there. Think about what that would do to the graph. How would that graph change if the rate were higher? Okay, it would definitely shift. Like which way? Payments would be larger if the amount you're earning is higher. So yeah, remember you got to think about is the payments you need to reach that goal, right? You're making more interest, so the amount of your payment could what? Go down, couldn't it? You could put less money in each month if the interest rate were higher, yes? Well, okay, let's say you put the same amount of money in, then what would change? So if we have a higher rate, yeah, like how? Okay. You could either have a lower payment to reach your goal, or what'd you say? Yeah, less time required, right? Or less time, like if you kept the same payments. So in other words, it would shift the graph which way? Carl, you said it would shift the graph. Okay, which is which way? Down, right? I guess it depends on which way you're thinking about it, right? In either case, like it's almost equivalent, right? Shifting left and shifting down. I'm going to say down seems more. Shifting it down will effectively shift it left, right? Is that, see what I mean? Okay. But in either case, you could either lower your payment or decrease the amount of time that you need to get that goal. Okay?